Good day, everyone. First and foremost, I'd like to thank our dear teachers for inviting me as one of the keynote speakers as we celebrate my alma mater's Science Month. I am Dr. Jayanne Bihag, an alumnus of Pateras Catholic School in 2010, currently a resident in training in the field of pediatrics. I'd like to share to you some updates on COVID-19, especially on variants and vaccines. A brief disclosure: I am not in any form affiliated to any pharmaceutical companies that may be mentioned in this report. Some of the slides are obtained from various webinars I've attended, both local and international. Here is the outline of my talk, and let's get started. Let's begin with the definition of terms. I'm sure everyone is familiar with these terms, but these are commonly misused, hence worthwhile to define. Mutation means an actual change in the genomic sequence. A variant is an isolate whose genomic sequence differs from the reference virus. It may or may not cause any change in the phenotype of the virus. Hence, it does not imply a worse or better virus. On the other hand, a viral strain is a variant that possesses unique and stable phenotypic characteristic secondary usually to accumulating number of mutations. And most importantly, please note the difference of SARS-CoV-2 and COVID-19. SARS-CoV-2 is the official name of the virus that causes an ongoing outbreak of the lower respiratory tract diseases, while COVID-19 is the disease itself that brought about by SARS-CoV-2 virus, most commonly presented with fever, fatigue, and dry cough. A review on the anatomy of the star of our talk. This is the structure of the SARS-CoV-2 positive sense single-stranded RNA virus. The spike or S protein is the primary antigenic determinant. At the very tip of this trimeric structure, or protein, is a receptor binding domain which binds to transmembrane ACE2 receptors on host cells, usually seen on the respiratory tract. If you stretch out the genomic structure of this protein and look on the S1 subunit, you'll notice the different variants circulating worldwide: the UK or the Alpha variant, the South African or the Beta variant, and the Brazil or the Gamma variant. These are brought about by accumulated mutations and deletions, which are also held stable from one variant to another and have an impact on the phenotype of the virus. Currently, we have four circulating variants named after the place of origin: the UK variant, also known as the Alpha variant, the South African variant, which is the Beta, the Brazilian variant, which is the Gamma, and most popular at the time, the India or the Delta variant. To have a wider view of these variants, we can describe each according to its transmissibility compared to the original Wuhan strain and the vaccine efficacy based on 2021 real-world studies. The UK or Alpha variant is 50% more transmissible than the original strain, probably thus cause more severe disease, but vaccines appear to be very effective against it. The South African or Beta variant is also 50% more transmissible than the original strain. We are still not sure if it causes more severe type of disease, but vaccines seem to be less effective. The Brazilian variant or the Gamma variant is believed to be more transmissible, but not sure if it causes more severe disease. And there is no great point estimate on vaccine efficacy since it is not circulating as widely as the first two variants. If I were to put another column here, I'll include the India or the Delta variant. As of, as of July 2021, the Delta variant has become the most recent variant of concern according to the WHO. It is 50% more transmissible than the UK and South African variant, hence 100% more transmissible than the Wuhan strain. Currently, it is known to have affected more than 60 countries in the world. And based on summary of reports, this variant may cause more severe illness in unvaccinated individuals. These individuals are far more likely to contract and spread the virus. Now that we have known the important structures of SARS-CoV-2 virus and its variants, let's proceed with the types of coronavirus vaccines acknowledged in our country. These vaccines may be classified based on the primary mechanism to which they mount an immunity against the SARS-CoV-2 virus. One of the conventional and most established way of producing vaccine is through inactivated virus technology, whose genetic material have been destroyed so that they cannot infect cells and replicate, but can still trigger an immune response. This is the same technology used for seasonal flu vaccines that are recommended that we receive every year. The most distributed vaccine in the country, the Sinovac Coronavac, is a type of an inactivated virus. Instead of using whole virus, another way of triggering immunity involves using just fragments of it, like the spike proteins. These vaccines are incapable of producing disease because these fragments are not able to infect host cells. However, they are less likely to be recognized by immune cells, which means they may trigger a weaker immune response. Because of this, adjuvants are sometimes added to boost stronger immune response and booster shots may be required. For this example, we have Novavax. Not all vaccines are designed to introduce antigens to the body. Some work by using cells in a patient's body to produce the antigens themselves. Examples include viral vector and mRNA vaccine. In both cases, the goal is to get a short fragment of the genetic code taken from a target pathogen, or in our case, the SARS-CoV-2 virus, into the patient's cells. For vaccines like Pfizer and Moderna, they work by hijacking the cellular mechanism, hence mimic the way viruses normally reproduce during natural infection. But rather than creating copies of the virus, the cells only produce large amounts of antigen that they usually trigger a strong immune response. On the other hand, viral vector vaccines such as AstraZeneca, Sputnik, and Janssen achieve this by inserting the genetic code for the antigen into a harmless virus, such as an adenovirus. This effectively acts like a delivery system to get the code into the cells without causing the disease. Vector based vaccines can be complex to develop, but they can trigger strong immune responses without the need for adjuvants. With hundreds of COVID-19 vaccines now in development, it is likely that a mixture of different approaches may be needed in order to stop the global spread of SARS-CoV-2 virus and end the pandemic. At this point, what we know and still learning is that COVID-19 vaccines are effective in preventing COVID-19 disease, especially severe illness and death. However, other preventive steps that help stop the spread of COVID-19 are still important, even as vaccines are being distributed. Here is one of the DOH campaign on COVID vaccine awareness. The Res Vacuna steps to encourage your friends and family and colleagues to get vaccinated when it's their turn to protect the country and the world. Let me just run this down to you. First is respect the author's opinion. Engage them whenever they are open to communications. Search for accurate information. Be empathetic and accept their context. Ask about what they feel and why they feel like this. Keep the conversation focused on getting vaccinated. Use stories of you and other people and their experiences. and never end the conversation on a negative note. And lastly, assist them on how to register for vaccination. And also note the apat-dapat of DOH, air circulation, physical distance of 1 meter or more, always wear mask and face shield, and 30 minutes interval or less. Finally, to conclude this short but very timely talk, please keep in mind that much of what we learned about SARS-CoV-2 for the past year will not be true today and going forward. Thank you for listening and stay safe.